ever hit send on like really strongly worded email and just instantly regret it? That, oh, no, there's no going back feeling.
I think we've all been there.
Right. Well, imagine that feeling, but in space.
Yeah.
Like a point of no return, except this time it's a black hole.
And you definitely don't want to hit send on a trip to a black hole.
Not a chance.
Yeah.
But seriously, you all sent in some fascinating stuff on these cosmic enigmas, so let's dive in. Black holes. Not even light can escape, right? We've heard the basics, but what's the deal with this warp in space-time thing?
Yeah, it's not just an empty void. Think of it this way. Like, imagine a bowling ball on one of those stretched out rubber sheets.
Okay, I can picture that.
The sheet curves around the ball, right? Gravity warping space-time around a black hole. It's kind of like that.
So how does a star even become this cosmic bowling ball?
So you've got these massive stars, way bigger than our sun, and they're just chugging along, fusing elements in their core, but eventually they run out of fuel.
And that's when things get interesting.
Exactly. The outward pressure that kept it stable, it's gone, and gravity just takes over.
So the star just collapses on itself.
Exactly, and it can trigger a supernova, an explosion so bright it's insane. Our source described it as, imagine a star many times larger than our sun suddenly imploding.
That's a dramatic way to go. So that's it. The star explodes and then boom, black hole.
Not quite. What's left is the star's core, and it's crazy dense, still being crushed by gravity. If it's massive enough, the collapse doesn't stop, it just keeps squeezing until you get a black hole.
And that's where the event horizon comes in, that point of no return we were talking about.
Think of it like, you're going over a waterfall in a kayak.
Okay, this sounds familiar.
There's a point where the current's so strong, paddling's pointless, you're going over no matter what. That's the event horizon. Cross it, and you're not coming back. Not even light escapes that pole.
And at the bottom of this cosmic waterfall, that's where we find the singularity.
Exactly. All the stars' matter crushed into a single point. Infinitely small, infinitely dense.
That just gave me chills.
It's a place where the laws of physics, as we know them, they don't work anymore.
It really makes you realize how little we know about the universe. We've got these incredible scientists, amazing minds, but some things are still beyond us.
Absolutely. And we've only scratched the surface. We've been talking about black holes formed from stars, but those are just one type stellar mass black holes.
Hold on, there are more.
Oh yeah, get ready for the supermassive black holes. We're talking millions, even billions of times the mass of our sun. And they live at the centers of galaxies.
Like celebrities.
Haha, kinda. Even our own Milky Way has one.
Wait, so our galaxy has its own supermassive black hole?
Yeah, it's called Sagittarius A.
Catchy?
Right. It's controlling things at the center, messing with the orbits of stars, even our sun.
I knew things were a little crazy here on Earth, but that's a whole other level. So does that mean black holes aren't just sucking everything up? Like cosmic vacuum cleaners?
That's what's so cool. They're more like galactic architects.
Architect?
Yeah, they play a key role in how galaxies evolve. It's a delicate dance, you know? Gravity, matter, energy.
Okay, I'm kind of with you.
Remember those jets and winds from earlier? Those actually can control how new stars form.
So a black hole can be destructive and creative at the same time.
Exactly. It's a balancing act on a massive scale. Black holes can suppress star formation, but also stimulate it, shaping the galaxies we see.
My brain's doing backflips trying to picture all of this. Okay, but let's get real for a sec. What would happen if I fell into a black hole?
Yeah, so picture this. You're approaching the event horizon.
Uh-oh.
And the gravity at your feet is getting way stronger than at your head. It stretches you out lengthwise.
You're saying I turn into a human noodle.
Basically. And then it gets even weirder. As you get closer, these forces intensify, stretching you more and more. Eventually, you'd be torn apart, even at the molecular level.
Okay, that's officially terrifying. So much for black holes being portals to other universes, right?
Speaking of portals, that brings us to wormholes. Maybe not spaghettification, but the cosmic shortcut idea is a bit more appealing.
Wormholes? Like those tunnels in sci-fi movies? You mean like shortcuts through space?
Yeah, like theoretical tunnels connecting different points in space-time. Imagine folding a piece of paper and poking a hole through. That's kind of how a wormhole might work.
That would make interstellar travel a lot easier. But how do black holes fit in?
Well, some think black holes, with all their gravity warping space-time, they could be entrances or exits to these wormholes.
So instead of being these cosmic dead ends, they're like Intergalactic subway stations.
Now you're getting it. Think about if we could use wormholes, we could travel to other galaxies, maybe even other dimensions.
My head is spinning. Okay, hold on. Before we get lost in the wormhole, what about Hawking radiation? I thought nothing, not even light, could escape a black hole.
See, that's the amazing thing about science. Always surprises. Stephen Hawking, he proposed that black holes aren't completely black. They actually radiate a bit of heat, which we call Hawking radiation.
Wait, so you're saying something can escape a black hole?
It's all about quantum mechanics. Things get a little fuzzy there. At the event horizon, you have these particle pairs popping in and out of existence. Sometimes one falls in and the other escapes as radiation.
So black holes are leaking energy.
In a way, yeah. And over a really, really long time, that could make them lose mass and evaporate.
Black holes can evaporate. Everything we've talked about makes them seem invincible.
Right. It really changes how we see these things. We're talking about timescales way beyond what we can imagine, but it shows that the universe is always full of surprises.
This whole deep dive is making me rethink everything I thought I knew about black holes.
Yeah.
We've gone from spaghettification to black holes evaporating. What could be next?
How about the idea that black holes aren't actually dead ends?
Okay, now you've got my attention.
Yeah, like what if they lead to other universes?
Like actual other universes. Our research mentioned scientists are looking into this whole black holes as gateways thing. It sounds like something out of a movie.
It's a pretty mind-blowing concept. Some physicists are actually starting to believe that our universe, as huge as it is, might just be one of many universes, like a multiverse.
Wait, so our universe is like one bubble in a bath full of universes, and these black holes are the way to travel between them.
It's a fun way to think about it. And if that's true, then black holes, warping space-time and all that, those could be the links between these different realities.
That's both incredibly cool and kind of terrifying at the same time.
Yeah.
But is there any actual science behind this, or are we just in the world of imagination here?
It's definitely still theoretical physics, but some really interesting theories are coming out based on what we know about things like quantum mechanics and cosmology. We're pushing the limits of what we understand about the universe, and that's always exciting.
So you're saying there's a chance you could fall through a black hole and end up in a universe with totally different laws of physics, different dimensions, maybe even run into another version of yourself.
The possibilities are pretty much endless when you start thinking about multiverses. It really shows just how much is still out there that we don't know. So much left to discover.
This whole conversation has been a wild ride, that's for sure. We've talked about how black holes are born, what they do, even how they die. We've uncovered some mysteries that still have scientists stumped, and we asked some pretty big questions that might not have answers. At least not yet.
And that's what's so great about all of this, isn't it? Each new thing we learn just opens up more questions and pushes us to try and understand the universe and our place in it a little bit better.
It really makes you feel small, but also incredibly curious at the same time. So for everyone listening, next time you're looking up at the night sky, just remember that those stars out there hold secrets beyond anything we can imagine. Black holes might just be scratching the surface. Keep asking those questions, keep exploring, and never forget that the universe is full of wonders waiting for us to find them.